A very warm welcome to Druids across the world to this, our second Druid Summit. My name is Peter Marshall. I'm a technology evangelist at Imply. More than 800 people have registered for today's incredible talks from the global Druid community. Following our first presentation by Gian Melino at Imply, it's time to offer my warm welcome to our second presenter of the summit, Raigon Jolly from TrafficGuard. All attendees will be on mute throughout the session, but that doesn't mean you can't get involved. Use the Q&A section of the Zoom webinar panel and we will pick those up at the end of the presentation. But any that we don't have time to answer today, don't worry, we will respond to those in a follow-up blog post. There's also live tweeting throughout, so be sure to follow us on Twitter. Links to the full presentation and the accompanying slides will be sent following the session. Raigon is head of analytics and data science at TrafficGuard, where he leads a team pioneering real-time fraud detection and reporting across cloud environments, leveraging both Google's cloud platform and Amazon Web Services. His team's mission is to reduce friction between data and actionable insights at massive global scale in a highly distributed environment. And in this presentation, he'll be describing how TrafficGuard is using Druid to fight ad fraud and bots. Raigon, welcome. This is something people will be super interested to know more about. So enough from me. The floor is yours.
Hello all. Thank you, Druid and Imply team for giving us this avenue to share our story on using real-time intelligence to combat ad fraud. I want to take this opportunity to thank our amazing data science team, the portal team, and the engineering team, without whom none of this would have happened. This, combined with the trust from our valuable customers, make this a story to share. I'm Raigon Jolly, Head of Analytics and Data Science at TrafficGuard. What is TrafficGuard? TrafficGuard provides measurement, verification, and fraud prevention for the digital advertising. As professionals in data-related roles, we know more than most rubbish in, rubbish out. In digital advertising, the presence of invalid traffic and ad fraud is the rubbish that pollutes performance data and impedes advertising performance. Ad fraud cost businesses over $42 billion in 2019. TrafficGuard provides reporting free from the influence of invalid traffic to help our advertiser clients get substantially more efficient and effective advertising. Invalid traffic from progressing through their advertising journey, then provide all-encompassing real-time reporting of the measurement and verification to advertisers so that they can adopt their advertising plans to generate more advertising results. This is all done in compliance with the industry bodies like MRC, TAG, and IAB. Continuing on, we are a global business headquartered in Perth, Australia, which is where currently I am based in. TrafficGuard is a subsidiary of ASX listed Ad Veritas Limited. We have an impressive and growing list of early adopters, each of whom are top applications in their corresponding regions and verticals. This includes the likes of Rappi, who are an on-demand delivery platform for the whole of LATAM region, and Gojek, who is the on-demand and multi-service platform, and even a digital payments technology company in Indonesia. We also have the likes of Glue, who are an American developer who publishes mobile games for smartphones and tablets. All of these customers are valuable and they are digitally savvy. We are a technology company with more than 50% of our team who are performing roles in engineering and data. And all this is across a span of 5 years. Coming to the ecosystem and the challenges that we faced prior to Druid. And these are the continued challenges that we have to solve day by day. We operate in a complex and data-rich, fast-paced environment, and our biggest data challenges are in these three broad spectrums: the journey, the scale, and the real-time nature of advertising. To start all this, we need data, and data, we get loads of that in many shapes and forms. Yes, we have the big four V's problem: the volume, variety, velocity, and the veracity of data. We have to connect to advertising platforms. We have our own JavaScript that are loaded from the websites. We have the SDKs in the client apps, and even the mobile measurement platforms send in requests. Also, we have storage transfers, which are historical transfers. All of these data comes to us from different data points and has different structures. The key element of fraud detection is user journey and the multi-point analysis that TrafficGuard offers. This is unique to TrafficGuard. In TrafficGuard, user journey is a key construct. Everything around advertising and especially fraud detection and the data processing revolves around user journey. There is multiple stages in the digital advertising ecosystem, right from the impressions to clicks, the conversion events, and the post-conversion events. The conversion events can be install of an app, a purchase of a product. Fraud detection happens in these three broad stages: during ad engagement, attribution. This is where the advertising source that brought the customer to the advertiser is attributed to, and in the post-attribution analysis. Legacy solutions typically look at one or two of these stages, but TrafficGuard's approach is to verify all the advertising engagements, even between the milliseconds of these engagements, so that the advertiser gets maximum ROI for the investments that they make. Next aspect that I want to talk is about scale. For each of these journey stages, there is lots of data with high dimensionality and cardinality. I am pretty sure you all have been in this stage, spending sleepless nights designing and supporting these systems. We have been there and done that, and it's hard. We had legacy systems which are batch-based, having 15-minute intervals of data freshness and supporting only a meager 15 to 20 dimensions. Designing systems like these to support 200 plus dimensions and 100 plus measures is hard. That's what we have to do for effective ad fraud preventions. And on average, we had to process 4,000 records per second. As a young company, the volume of data we process is growing rapidly. Our workloads are spiky, and we need a flexible infrastructure that can scale accordingly. What you see here is the growth of data. We had 30x growth last year. 30x growth should not be amounting to 30x growth in the cost of the system. Given our scale, compute, and storage requirement, the cost of in-memory systems does not make economical sense. From here, the enrichment is a valuable asset like the data itself. A proper enrichment is the backbone of good data analytics and often the most challenging in terms of data quality and governance. Taking all available data into account enables TrafficGuard to provide the deepest understanding of traffic and provide reliable validation. Unlike our competition, who only takes part of the data, oftentimes lacking the same enrichment that we were able to pull together from the deep experience of 5+ years of fighting ad fraud, we have a treasure trove of data assets and data enrichments. The data enrichment can be of the user journey. It can be the enrichments of the time in local time, the IP enrichment, the network intelligence that we get, the user agent enrichment, the device enrichment, journey enrichment, and the multitude of campaign and partner source enrichment. All this amounts to huge challenges. The next challenge that we have to solve for the digital advertising landscape is the real-time nature. There are two broad spectrums around this. One is the event to reporting time in real time, which for us, we want to do that in T plus 5 seconds. That is right from the time you click to the time it appears in an analytical system. We can only afford 5 seconds. The next aspect is the verification in real time. Here, this is counted in milliseconds. And for this, feature stores are critical. We wouldn't be able to query a data warehouse directly and compute features to inform validation in short time periods. But using feature store, features are pre-computed in batch processes in systems like Redis, which enables low latency queryability. We use Druid as an aggregation platform to fuel the TrafficGuard's feature store. To achieve real-time reporting means processing thousands of queries at peak in high concurrency. And with billions of data, 2000 plus dimensions to report from and 100 plus measures, these challenges compounded with a fast growth led to us choosing Druid. The first initiative that we wanted to solve using Druid is the time series analytical layer, which is a fast query access to the customer. The key aspect here is the granular reporting capability to the client, where they have log level insights across different aspects of measurement and validation. And here again, many of our competition only provides aggregate data reporting. We have 14 plus reporting subsection in our product, which is what you see in the right. And some of the subsections have 18 different components that are all concurrent queries with even things like time period comparisons. All this amounts to, as I said, like 1,000 queries a second, which has to be, again, the P98 expectation from the business is these report come back in less than 2 seconds. One more thing that we were able to achieve with Druid is, since SQL is a language that it talks, it helps us to not learn another language for reporting, but it helps to streamline the development of our portal reports, helping us to bring analytics faster to the market. The next aspect that I wanted to share is some of the best practices as we evolve the system. Know your large clients. Your large clients will show you how strong is your change in the system. Identify the top 3 or 5 of the large clients and separate them into their own data sets. Have an operational reporting layer with a lifecycle policy such that you can have row level access to data and have a unified reporting for analytics, which has large roll-ups across time so that we can do historical trending and forecasting. Govern your KPIs in pivot and have role-based access and even version your definitions because semantics of KPIs can change. Pre-calculate commonly used fields into one field. Define differences between a null and an empty field. In our case, null is not set. Define a data retention policy, data lifecycle policy, data tiering, and have a multi-strategy early on and plan it well ahead. Remove case statements and time extract and rejects in your group by clauses. Continuing on the query optimization, have a sound data dictionary. This is a key foundation on which many of good data governance goes well with. Keep your name in systems, especially in Druid, descriptive and maintain the lineage when possible. Also, Druid does not support mutability of records. So have a data strategy and a data engineering process, both for real-time and batch adjustments. Use Clarity as a proactive monitoring system combined with the CloudWatch or the Stackdriver metrics that the cloud vendors provide. If dimensions are commonly used for count distinct and a high cardinality, use the probabilistic data structure like the theta sketches for measures. Maintain query performance of commonly used queries so that you can benchmark the query performance across the evolution of Druid versions. Use Druid's new management capability to monitor your segments and even the health of auto compassions, which is really important to your query performance. The other aspect that I wanted to talk about is about Clarity itself. There are key learnings that we could get. By default, the SQL query ID is a random number, but through the API, you can provide a SQL query ID that maps back to your product namespace such that you can point to a product area, identify who and what people are using the system through the identity feature that is available, again, passed through the API. Likewise, identify your commonly used dimensions, identify the number of metrics that people query on, and you can always look at what are the complex metrics, and these complex metrics can be pre-calculated at the ingestion time or at the workers that send data to Druid. Look at pre-calculating some of these commonly used dimensions. Also, look at the duration, which will help you to look at concepts like data lifecycle policy and data tiering. There are different types of Druid queries, which is extensively documented in Druid, and also have governance and proactive monitoring on the P98 query latency. These are often key leading indicators to any cluster issues that may come up. From the operational reporting that Druid was able to serve us, we were happy to announce that we are also using Druid as an operational data store. This is another critical aspect of real-time intelligence, is the access to the raw request early on to tackle data quality and operational monitoring requirements. Data quality is paramount to data science workloads, and monitoring system gives the teams across business so that it's not a siloed information. Across business, anyone can come and access the data quality. This is especially relevant where multiple teams like a customer success team would be working with the client integrations, and catching issues early on at integration and enrichment is paramount to the quality of our detection. We have tried Elastic Kibana Stack, and we had failed to get the value from it because of the reliability concerns and the operational overhead. The system was costing us close to 30,000 USD per month and upwards, and still it was not performant. But we were happy and surprised that on a day we just pointed the real-time source to Druid and it outshined the ELK stack. And we were able to adopt it across the business thanks to the ease of pivot and the speed of Druid queries. The other aspects that we use the operations data store is for data profiling, which is key to many of the aspects downstream. These are looking out for nulls, looking at missing, looking at even unique high cardinal information, and spikes and drops in traffic. We are able to quickly identify data quality issues, and it helps us to test integrations because, as I said earlier, the event to reporting time is just 5 seconds. You do a click and you get access to the raw level information as well as analytical information when needed. The other aspect of the analytical layer is threat hunting and prototyping. As we have access to the data, then it is paramount as a fraud detection company to have interactive analysis and multivariate analysis. We are going here to this layer of pivot to find the unknowns, to look for correlations, patterns, and emerging trends. Threat hunting happens here, and everyone in the company are citizen data investigators. The ad-hoc questions like what, why, how, or show me more. Each of this is available to us at the speed of thought. And each of these conversations lead to treasure trove of findings in the infinite sea of connections in the data. The key to successful machine learning and unsupervised autonomous systems are the human in the loop. We have to govern the system. We have to have monitoring capabilities. And this needs to happen across the arsenals of pattern detection, outlier detection algorithms, the rules engines, and it's a complex art to monitor this. For this, we use Druid and the capability of Pivot. We have systems to monitor our processes. There are three facets of this. One is the ability to look at data drift, the ability to look at concept drift, data quality issues, and the health of our data engineering processes. Let me just brief about this system of like a data quality or a data engineering process. As you see in the middle, this is a real production dashboard where you can see across the time in a day, the different rules that get invoked because of different fraud that are happening for different of our advertisers. As you see, there are certain swim lanes that are white. This might indicate a quality issue, engineering issue, or a concept drift. With one click in Pivot, with the multifaceted dashboard, we can go and drill down to information on what exactly caused that particular issue. Concept drift is an effective, for any effective data science system, the ability to catch this, the cause and effect, is really important. Coming to the other surprising aspect that we use Druid is in the streaming layer. This is one of my favorite and most valuable areas that I am currently invested in. Streaming and feature stores adds fuel to realize our ML and AI milestones. We started this initiative 2 years back. I wanted to just explain what a feature store is because I touched upon it earlier. It's a real-time store. In principle, it stores the key and values are the key business metrics. In our case, these are dynamic calculations of risks that we store for real-time validation. The system currently has evolved as we are adopting modern technologies and we are investing engineering resources. And we are looking at advancements in systems like Apache Beam on a data flow runner with a real-time ML capabilities. But 2 years back, we did not want to invest on immature and often operationally overloaded streaming ecosystem. But we repurposed and morphed Druid to act as a streaming layer as it gets real-time data from AWS Kinesis. We use Spark to batch load this data into Redis, which is the in-memory system, which can give the fast millisecond response for our workers, which are client-facing. This system is still in production and actively used. The next aspect that I wanted to talk about is the ability of Druid to serve across the data value chain. There is the concept of data aging. When the record comes in, the record is valuable on its own. ability to see that record, as we have seen in the operation system, is really valuable. And as the data ages, the value becomes in aggregate. And this is where our analytical data sets are really useful in Pivot. And across the value chain, we use Druid, and it then becomes an economical proposition. All this is done through the partnership with Imply, which was a multi-year engagement. And Imply, being the creators of Druid, are the experts who have deep understanding of the problems that we are facing with the time series analytical databases. And what we truly believe is Imply are the masters of Druid, and TrafficGuard are the masters of finding ad fraud and preventing them. And this is where, because of the ability of Imply to take care of our Druid and the updates and the rolling updates to Druid, Clarity, and Pivot, we are able to focus on last mile and deliver value for our customer. The consultation and the guidance that Imply provides us is massively valuable. And they keep our operational overhead to a minimal. With Druid, what has TrafficGuard achieved? And it's been a multi-year engagement. But currently, we are happy to tell that all of our page loads, the P98 is even less than 28, and most of the reports load with less than 5 seconds at high concurrency. 70% of our analytical needs is powered by Druid, and all of us are data citizens. High dimensionality and cardinality of data is not a challenge, it's an asset. We use it. And there is immediate and significant cost savings from Druid. As you see, Druid performs a role in our system for time series analytical system. It's an operational system. It feeds a feature store. It is the backbone of our analytics, and it helps us to prototype for a customer-facing product. We are super confident of our continued journey with Imply and the Apache Druid community. We look forward to the advancements in areas like faster data access, data visualization, machine learning, and anomaly detection capabilities inside Druid. This has already surfaced to us in systems like alerting and explain data, where you point and click on pivot, and it automatically breaks down the dimensions across millions of time series, looks at the different infinite dimensional combinations, and tells us the result of a spike. And this is amazing technology, and this is where I know the community is going towards also. We look forward to the exciting times ahead, serving our customers, innovating in technology, and reducing dollars wasted on ad fraud. And we wish everyone a safe and wonderful day ahead. Thank you everyone in the audience for your time, and thank you everyone in the team to support me. Thank you.
Raigon, thank you so much. Wonderful talk. Thank you for your time today. I'm clapping, everybody else is clapping too. Brilliant. Thank you so much. So I love that you're all data citizens. That's fantastic. I love that. And yes, cardinality is an asset. It's not a problem anymore. Awesome points. Thank you so much. So we have some questions from your audience today. Please keep contributing questions. If you've got anything to ask Raigon, please continue to add them. And if there's any that we don't answer, as I mentioned before, we will get those back in a blog post to follow the presentations today. Okay, Raigon, are you ready? Here's one I'm actually quite interested in as well. So you mentioned when you were doing your query optimization, you had to remove the case statements, you had to remove regex. I think there was a third one as well. I'd like to know why you had to do that. So what was the reason for that? But one of the questions is, did you find that applied to all inline functions as well? So two parts there for you.
Yeah. So yeah, we had requirements, there are different data query patterns in Druid. And when you add certain complex measures into the group by, the more optimal query type actually changes. I don't remember back of the mind the exact query type, but you can see that add a statement into a query type, and you can see in the Druid explain plan that the query type changes, and even the performance takes a hit as the query plan. So what we are looking for are effective roll-up queries and the effective query type that Druid performs. And this can be actually gathered from the explain plan when you write a query, and you can see the query type that was there. And this had to be done across the board, and actually Imply consulted us on this and made the changes for us. Otherwise, I think the literal term is it becomes a scan type query and does not perform the rolled up, efficient query type.
Right. That sounds like that was quite an iterative process that you had to go through to find that.
Yeah, and this is where I think this was a like we had a query performance as we scaled, and we were not proficient earlier on in the time series query patterns, and this is where the consultation of Druid and Imply team also came into effect, and we had to actually snapshot our queries and through a iterative process work with the Imply team. And in fact, it was a suggestion from Imply team, and we could easily notice 50x change just by this tip.
Wonderful, thank you. So I'm going to stay with the question about the actual analytical functions. So we've got a couple of questions relating to that. Druid, the question is that Druid seems to lack some basic analytical functions like lead and lag. So how did you get around that?
Yeah, so one of the aspects of our data strategy is we have multiple peers that support Druid. Druid is not the only system. We have other data warehouses like BigQuery, Athena, where when we have a complex requirement, we then move on to that. So we have data coming in real time to both these systems. And when we need like analytical window functions and rank functions, then we move on to system. But I do notice that Druid has also incorporated SQL as a first-class citizen. And I think with the drive, like people like GN, I think window functions are not far off. I can see already feature requests coming in. And with things like join, which recently came in, I think more of the SQL and ANSI standards are coming into Druid.
Sure. Thank you, Raigon. And a question about the data enrichment. Do you find that Druid's capable of doing data enrichment at scale with these data dictionaries stored inside a Druid data store, or are you doing something different? How did you approach data enrichment? Can you tell us a little bit more about that?
Yeah, so data enrichment for us happens from our engineering team right at the, for us at the workers. So we do the location intelligence, the IP intelligence from historical. So basically from historical data, we push it to real time and it's all available right at the workers. All the enrichments happen there. And to Druid, there are then in Druid, the suggested approach when you want certain enrichments is then either to load it up from S3 or from Postgres. But the volumes, it's not meant for like high cardinality data. It's meant for like, say we have organizations and we want to get organizational metadata and the latest data. Then we have the Postgres lookup that serves those organizational metadata in real time. But all of our custom enrichments happen way up as the data comes in, because the value, what we have seen that is the value of enrichment is not only inherent to Druid, but even in the other subsystems. So the way up you can do it, then the access of the data enrichment is available in these multiple layers of your data system.
So you had to make a decision about the enrichment. I've been asked that question myself in talks that I've done, where people have said, should I enrich the data at ingestion in Druid? Should I enrich it at query time? Should I enrich it further upstream? It sounds like you've had that same question yourselves as well.
Yeah, and we have an amazing engineering team also who helps us out with this. So some of the early decisions were in combination with engineering and us. And what we find is, as we fan out information from systems like PubSub or Kinesis, uh, as we build multiple stacks of real-time streaming and analytical needs, it's always better if you can to do that enrichment in stream. And that's, I think that is where even the streaming ecosystem is going to, is during that ingestion process, before you put to systems like PubSub or Kinesis, do that enrichment so that any fan out system can get those same enrichments.
Thank you. I have an anonymous question that's come in, and I'm guessing this is someone in the community. They would like to know who first told you about Apache Druid.
Yeah, nice question. So I think, I think it's a good question. So for me, it's been an endeavor since I joined here to solve time series. So part of it is we have been there and done that. We did try to build our own system using like traditional ETL tools. And part of that was the when we had challenges, we were able to get it operational, but it was not meeting our growth and other strategies like even the, because what we noticed is, though we build the data warehouse, your BI is separate and your data is separate. And where we are heading to is, if systems like Druid, like in Imply, everything is in one system. So we don't need to then have another, like a Tableau or another extract of data for the concept. And part of that evolution is we are looking at for, I think it was a Google search, and then we found basically the history of Imply, and since their roots were from advertising, that clicked on to us, and then we then started discussing with the Imply team, with I think with approval from Meta Markets, because initially they were thinking that we are also in the performance advertising domain that they were working on, but with all the blessings from Meta Market, I think we were one of the early customers of Imply, and we are happy with this, how it transforms to. And I truly believe data systems are where, I think where I can see other systems as well as Druid going is, you get, it needs to support your streaming use case, your analytical use case, and your ML use case. And whichever system does this all well, that's where I think the value will be and where people continue to find value.
Yeah, I'm very glad to hear you say that. So I've got a couple of questions that are about other alternative technologies. One question about whether you tried other time series databases, like did you try OpenTSDB or Prometheus or things like that for the time series data? And then I have another question, which is a different kind of question, but is whether you saw a real cost reduction after you moved from Elk into using Druid. So yeah, maybe if we start with this question about time series databases, I'm very interested to see lots of people who are moving to Druid from time series databases. Was that very similar for you?
Yes. So we started with AWS Redshift as a data warehouse. It was performing okay, but with the caveats of operational overhead. We did have early POCs on Kylene and Elastic. Both of them did not work. And around last year, we did try even OpenTSDB. And there are, because it is based on the HBase, and if you look at the system, it's good for IoT use cases, but with the 200 plus dimensions, the 100 plus, and the lack of, so basically all these systems, you then have to maintain the BI layer, which becomes a real nightmare when you're trying to focus on the last mile and build the AI and data science capability. So we did try OpenTSDB, had conversations with Kylene, Redshift, Where we are finding current values with systems like BigQuery, with I think with the ability to stream data in real time and then find ML. So that's where currently we are looking at. But Druid is clearly has its clear strengths when it comes to the key strengths that Druid offers. The next part with the cost savings of the ELK stack, for us it was a $0 cost. So that was basically a real win for us because, as we said, we were spending nearly $30,000 per month on the system. It performs okay, but it's not. I think it's not meant for the high dimensionality of data and the real low latency access that you get to. There are strengths in certain areas, like how you can read a JSON body, but I think what we are able to do that we are able to kind of morph pivot like Kibana, because you can click and it offers even more faster speed than Kibana. So for us, it was just a one-day decision to just switch on Druid for our operational needs. So these are currently like the last 7 days data where we have raw access to data. And that was basically a $0 cost because it was just connecting to Kinesis, and that's it. And then that's, and it actually probably even helped our infrastructure team to stop supporting ELK stack because that was also, that version of ELK stack was not even having the Firehose connectivity. So we had to build the Logstash to ingest data to ELK. But definitely it did not serve our needs, but Druid did quite well. And actually, I had to just comment on the Imply support team as well. Is when we had certain performance issues, but the support and the proactive support that they continue to offer the whole of this year has been pretty awesome. Like kudos to the support team, people like Daniel and Abhay, like they are full on, and I think they appreciate the partnership. And I thank you to Imply team for offering us the support.
That's very kind of you. Thank you, Raigon. Thank you. I've got a couple of questions before we sign off. One question is about how big your actual cluster is. How many Druid servers of what types have you got? I know you mentioned tiering already. Could you give us a kind of an idea of, for this volume of data you were talking about, how big those clusters actually turn out to be?
Sure. So we currently have a i3 4x large, and then we have currently around 13 to 14 of them. Last time I remember, like 14 data servers, and then the supporting other supporting master nodes and query servers. But we have around 14 i3 4x large. Currently, it's hosted in AWS infrastructure, and the real-time source is from Kinesis. So that's our current stack. And for the operational data store that we have, there it's like last 7, and even the raw request, oftentimes it's like the whole request body and request URL. So we want granular access there as well. It's quite massive because there's no roll-up achieved because it's per transaction. There we do the data lifecycle policy. Basically, after the 7 days, there's continuous expiry of records. At the current moment, all our data is in the hot tier. So there is no data tiering as such because our customers, we want the ability for our customers to go at any point of time and still have a really low latency access to data. So most of our, we haven't, in the analytical layer, we haven't implemented the data tiering because all of our data is hot.
Lovely. Well, Raigon, I could continue talking to you all night, I think. But I'm afraid we're going to have to draw things to a close today. Please, everyone who's asked questions, thank you so much for that. We are going to come back to you with answers in a blog post. Raigon, thank you very much for speaking to everybody today. Thank you, everybody, for your questions. As we mentioned already, all the links to all the slides and to this recording will be sent to us at community@imply.io to tell us your own Druid stories and to get all the latest information on programs that are running across the world. Do join us for our next session. We'll be describing building an enterprise-scale dashboarding and analytics platform powered by the capabilities of Druid. It's from Target's principal engineer, Jeremy Wolfel. It starts in about 15 minutes at the top of the hour. So I'll see you all there. Thank you, everybody, so much. Speak to you soon.